more nervous system. So this is the autonomic nervous system. So this is the part you don't have to think about, but you have to think about it to learn it. Sorry. Um, but normally the way it works is it just happens. You don't think, it just goes. All right. So we're going to divide this up. It regulates everything. Takes care of stuff, so we don't have to think about it. That's all. Now, the way it communicates is the afferent and efferent. So afferent is adding information to the brain, efferent is taking information away. And everything kind of, it's weird, it's hooked up into a ganglion, so it kind of wraps around the spinal nerves and makes its own chain. So it makes its own chain going up along the thoracic vertebrae, and that is going to be your sympathetic nervous system. Your parasympathetic is up in your spine and going down more into your sacral region. Okay. Let me see. So autonomic, basically, visceral, sensory, stuff like that. Somatic nervous system we can control, so that's going to be your skeletal muscles. Okay. I don't want to do the comparison. Just understand that in the autonomic nervous system, we have our sympathetic and our parasympathetic and then our enteric. The main thing you have to be aware of is sympathetic amps you up, fight or flight. Sympathetic is, it's going to be releasing acetylcholine, which gets your muscles ready to go. It gets everything stimulated. So it has this. Some drugs have a cholinergic effect where it actually amps you up and gets things going. So your sympathetic is your fight or flight. It is basically, think sympathetic as that's your meth. Okay, so it gets you going. Heart's racing. Your lungs dilate. Your pupils get bigger to take in more information. You're not hungry because all your blood is going to your muscles. We shunt the blood away from your stomach. As a matter of fact, under sympathetic, your spleen pumps out more red blood cells so we can carry more oxygen. So your sympathetic amps you up, gets you ready for fight or flight. Parasympathetic brings you down. Your parasympathetic is after the Thanksgiving dinner when you scratch your belly button, undo a couple of buttons, just want to sit there and watch the Detroit Lions lose again. It is the rest and digest is what they say, because the blood goes to your digestive tract to try to get the nutrients. So it looks a lot happier. So you can basically think about your parasympathetic. So if your sympathetic is like your methamphetamines that amp you up, your parasympathetic is going to be more like your Quaaludes, but Quaaludes are also, it's going to be more like your Xanaxes. That kind of make you calm down and relax. They're your chill pill. Okay. Your enteric, though, is the one that actually controls your digestive system. So just leave it at that. If you have a problem with your digestive system, you go to a gastroenterologist. Enterologist means enteric nervous system specialist in that. Okay, we can talk about all the ganglions, but it's going to be easier when I actually show you. Just know the sympathetic is in your thoracic region, so it's your sympathetic trunk, sympathetic chain, things like that. So sympathetic, all the nerves, they line up, and you'll understand it a little bit. But what they do is they take the information, they send it over to the ganglion where it's going to synapse and start to send it up the chain and target organs. I want you to understand. This part right here is, let me get into the drawing. So this right here is neurons. So this is going to be motor neurons going back down. This here is hormones. Okay, so it's going to, the sympathetic is going to actually make you release hormones that are going to go to your adrenal glands, so you release adrenaline to keep you even more amped up. Goes to your spleen to make your spleen squeeze and push out more red blood cells. So once again, fight or flight, amps you up. Okay. Adrenal medulla is in your adrenal glands, which are on top of your kidneys. I don't really worry too much about you understanding all this. I just want you to see how your sympathetic chain comes up as ganglion, where we're going to synapse, we have all the nerve bodies and everything like that. And what it does is it can send over and it kind of joins up. Okay, remember, this right here is your dorsal root. This is your spinal nerve. This kind of jumps right into your spinal nerve. All right? So, communication coming out, comes out, motor, goes running down, goes around, and synapses over here, your sympathetic, goes out to your target muscles, target tissues. This is where I want you to actually understand it. So this is going to be your spinal nerves right in this area, and the chain actually, it kind of loops around. So it loops around, loops around. Almost makes like it uses your spinal nerves kind of like a ladder as it's running up. Okay. So that is what they mean by preganglionic synapses, postganglionic synapses. Okay, yourself there. Okay, collateral just means it's that chain. They all come and hang together. It's an easy one, but it's really easy to get confused. So your adrenal medulla makes epinephrine and norepinephrine. Let me see. Epinephrine and norepinephrine, they cause like your heart's going to beat harder under the epinephrine. Norepinephrine is going to make your arteries dilate, so you get more blood through them. Those are the main players you need to know. Yeah, it's your medulla, your adrenal gland. We'll talk about that a lot. It's on top of your kidney. Okay, so effects of sympathetic stimulation. Increased alertness, energy euphoria, cardiovascular activity, respiratory activity, muscle tone, mobilization of energy reserves. So once again, what does this do? That's all amping you up. Okay, let me see. Alpha receptors and beta receptors. I want you to be aware of this because an alpha receptor is going to be on an artery. So an alpha receptor, what that does is it's going to make the arteries open up. So if you have high blood pressure, we put you on an alpha blocker. It's going to make your arteries not react to that. Okay. A beta blocker, beta receptor is in your heart. So that is where your epinephrine goes. So we put you on a beta blocker. So your heart's not going to be affected by your adrenaline as much. Okay. When we talk about cardiac, we'll go into more of that stuff. Yeah, acetylcholine, muscles. Don't want to go crazy. This is easy to get lost in. Parasympathetic does the opposite, okay? So parasympathetic, what I want you to know on this one is parasympathetic is up in your cervical region and going down into your sacral region. That's all. It doesn't make hormones get released. What it does is it stops the glands from producing the hormones and releasing them. So it just, once the parasympathetic kicks in, the sympathetic stops. You never have both working at the same time. You just understand it like that. And as you can see, they come directly out from the spine. They don't have like the chains, the little loop chains that go around. They don't have those presynaptic ganglions like in the sympathetic. Right? So that's the big difference when it comes to how they're controlled. Yeah, this is what it does. You know, we could all use a little more parasympathetic in our lives, but we seem to just have sympathetic normally. I don't want to go into too much of this stuff. Now understand that our parasympathetic, it hits our brain, it has nicotinic receptors. Nicotine hits those too, which is why it is so hard to quit smoking. Let me see. It's all pretty much telling you the same things. So as you can see, here's a sympathetic trunk. It's in the thoracic region. This chart, I would suggest you learn this chart. Okay, this would be something you should know. Other than that, this is an easy one. I don't want to go too crazy on this one. Alright, so I think we're good there.